Welcome, developers and tech enthusiasts. Today, we're diving deep into a critical topic for anyone building on AWS, securing S3 buckets. Amazon S3 is the backbone of cloud storage for countless applications, from static websites to massive data lakes. Its simplicity and scalability are incredible, but this power comes with a significant responsibility: security. Misconfigured S3 buckets have historically been a source of major data breaches, leading to financial penalties, reputation damage, and loss of trust. We're not just going to talk about security, we're going to demonstrate common pitfalls and then walk through how to secure your buckets using both the AWS command line interface and Terraform. First, let's understand what an S3 bucket is at its core. Think of an S3 bucket as a highly scalable, virtual folder in the cloud. You store objects, files, images, videos, documents, inside it. Each object has a key, its name, and can have metadata. S3 is designed for 11 nines of durability, meaning your data is incredibly resilient. However, durability doesn't automatically mean privacy or security. The fundamental issue we often see is unintended public exposure. Imagine a digital safe, but someone accidentally leaves the door wide open for the whole internet to peek inside. This happens when bucket policies, ACLs, or block public access settings are misconfigured, allowing anonymous users to read, or even write to, your sensitive data. To really drive this point home, let's start by creating an intentionally insecure S3 bucket using the AWS CLI. We'll simulate a common mistake, explicitly granting public read access. In our demonstration, we'll execute a script that uses the AWS S3 API create bucket command to provision a new bucket. Crucially, it then applies a permissive bucket policy, essentially a public allow S3 get object rule 4 principle, asterisk, meaning anyone on the internet can retrieve objects. Additionally, we'll upload a sample text file and configure its access control list, or ACL, to public read. Finally, to ensure our public policy and ACL take effect, we'll explicitly disable S3's powerful block public access settings for this bucket. This setup will give us a perfectly vulnerable target for our next step, demonstrating exactly what not to do in a production environment. With our insecure bucket now deployed, let's verify its vulnerability and witness the potential for data exposure. We'll run another AWS CLI script that first inspects the bucket's configuration. It checks the public access block settings, which we expect to be entirely false, indicating no public access is being blocked. It then retrieves the bucket policy, confirming the presence of that alarming principle, asterisk and S3 getObject statement. We'll also examine the object's ACL, verifying that elusers have read permission. But the most impactful verification comes next. We'll use curl to directly access the sample file via its public S3 URL. If everything is misconfigured as intended, curl will successfully download the file, revealing its contents. This simple act dramatically illustrates how easily sensitive data can be compromised when S3 buckets are left unsecured, making it a critical lesson in cloud security. Now that we've seen the danger, let's talk about defense. Securing S3 buckets relies on a few fundamental pillars. The first, and arguably most important, is S3 block public access. These are 4 settings that, when all set to true, prevent any public access through ACLs or bucket policies, overriding even conflicting configurations. Second, server-side encryption ensures your data is encrypted at rest. Whether it's SSE, S3, AWS Managed Keys, SSE KMS, your keys managed by KMS, or SSEC, customer-provided keys, encrypting data at rest is a non-negotiable best practice. Third, versioning provides crucial protection against accidental deletions or malicious overwrites, allowing you to recover previous versions of objects. Finally, access logging records every request made to your bucket, creating an invaluable audit trail for monitoring, security analysis, and compliance. Together, these form a robust foundation for S3 security. Let's put these security pillars into practice. We'll use another AWS CLI script to transform our dangerously exposed bucket into a bastion of security. The first and most critical step is to enable all 4 S3 block public access settings for the bucket, effectively shutting down any avenues for public access, regardless of existing policies or ACLs. Next, we'll remove the previously applied public bucket policy, ensuring no rogue policy can grant access. We then enable server-side encryption by default, using AES 256 for all new objects. Following this, we activate versioning, so every change to an object creates a new version, providing a safety net for data recovery. Finally, we configure access logging. This involves creating a dedicated, highly secured log bucket, setting appropriate permissions for S3's log delivery service, and then instructing our primary bucket to send all its access logs there. This comprehensive set of commands quickly and effectively secures the bucket. With our security measures applied, it's vital to confirm their effectiveness. We'll execute a verification script that systematically checks each security control we just implemented. First, we'll query the bucket's public access block configuration, expecting to see all four settings: block public ACLS, ignore public ACLS, block public policy, and restrict public buckets, now proudly display true. We'll confirm that no public bucket policy is active, or if a policy exists, that it strictly adheres to least privilege principles, never granting public access. We'll also verify that default server-side encryption is enabled, typically showing AES 256. The script will then check the versioning status, which should report enabled. Finally, we'll ensure access logging is correctly configured and pointing to our dedicated log bucket. To give us the ultimate assurance, we'll repeat the curl test from before. This time, we fully expect it to fail with a 403 forbidden error, definitively proving that our bucket is no longer publicly accessible. This step provides tangible proof of our successful security hardening. While AWS CLI is fantastic for scripting ad hoc changes or integrating into CI/CD pipelines, for managing your cloud infrastructure consistently and repeatably, infrastructure as code, or IAC, is the way to go. This is where tools like Terraform shine. Terraform allows you to define your AWS resources, including S3 buckets and all their security settings, using declarative configuration files. This means your infrastructure state is version-controlled, auditable, and easily replicated across environments. Instead of manually clicking through the AWS console or writing imperative shell scripts, you define the desired end state, and Terraform ensures it's met. This approach drastically reduces the risk of human error and ensures that every bucket deployed follows your organization's security best practices by default. It's security built into your deployment pipeline. To illustrate the power of Terraform, our demonstration code includes two distinct configurations, one for an intentionally insecure S3 bucket and another for a fully secured one. We use a helper script to manage their deployment. For the insecure bucket, the Terraform configuration explicitly omits public access blocks, and crucially, defines a AWS_S3_bucket_policy resource that grants S3 get object to principal, *. It also forgoes default encryption, versioning, and logging. When applied, this mimics the exact public access scenario we demonstrated with the CLI. Conversely, our secure Terraform configuration defines all the best practices we discussed. It includes AWS_S3_bucket_public_access_block with all settings true, AWS_S3_bucket_server_side_encryption_configuration for AES 256, AWS_S3_bucket_versioning set to enabled, and AWS_S3_bucket_logging directing logs to a separate, secured log bucket. Deploying these configurations side by side vividly demonstrates how IAC allows you to enforce security standards from the very beginning of your infrastructure lifecycle. Beyond these core pillars, there are additional best practices to elevate your S3 security posture. First, implement least privilege. Ensure IAM users, roles, and services only have the exact permissions they need to interact with your S3 buckets. Avoid wildcard allow * statements unless absolutely necessary and scoped tightly. Second, consider multi-factor authentication, MFA, delete for critical buckets. This requires an MFA code to permanently delete objects or suspend versioning, adding an extra layer of protection against accidental or malicious data loss. Third, regularly review policies, periodically audit your bucket policies, object ACLs, and related IAM policies. AWS config or third-party tools can help automate this. Security is not a one-time setup,